Hello and welcome back. In this new section, we're going to now move on to a more advanced networking topic and start to talk about high availability and fault tolerance. So we're going to now work back over to the physical and networking layer and drill down to our networking VPC diagram. So let's click on regions, availability zones. We'll show the VPC, dive down into that, and then enter our VPC. So over here on the left-hand side, there are several different types of network configurations that I want you to pay attention to. And right now, we're going to move from the basic VPC diagram, which we have been working with to this point, to our highly available and fault-tolerant VPC diagram. Now, what you will notice is that the difference between the two mainly is that now we have introduced something called an ELB, or an elastic load balancer, and also something called an auto scaling group. So what I'm going to do for the remainder of this lesson is talk conceptually about both of these and how they work, and then following this there will be a lab in which we'll go in, create an elastic load balancer and an auto scaling group and get them working together. So first, let's touch on what an elastic load balancer is. And if you want to find that over here on the AWS console, you can do that by coming to the EC2 dashboard and then scrolling down and clicking on load balancers. So what is a load balancer? Well, a load balancer as a concept is a common method used for distributing incoming traffic among servers. An elastic load balancer is an EC2 service that automates the process of distributing incoming traffic evenly to all the instances that are associated with the elastic load balancer. An elastic load balancer can load balance traffic to multiple EC2 instances located across multiple availability zones. That's very important to remember, is it's one of the main purposes of an elastic load balancer because this allows for highly available and fault-tolerant architecture. Also, elastic load balancing should be paired with auto scaling, which we'll talk about next, to enhance high availability and fault tolerance and allow for automated scalability and elasticity. An ELB also has its own DNS record set that allows for direct access from the open intranet. So again, now having that conceptual understanding of what a load balancer is, let's go back out to our diagram and take a look at where its place is in the diagram itself. So for this example, let's say that we're hosting a web application. So these two EC2 instances are hosting HTML files that we want to serve up when requested from our customers. So our customer enters our web address into their browser and it comes in through the open internet, hits the internet gateway, and then hits the elastic load balancer. The elastic load balancer will then take the first request for traffic and send it to this EC2 instance. It will then take the second request and send it to this EC2 instance, and so on and so forth. So it's going to balance the traffic between these two EC2 instances so that one EC2 instance doesn't become overloaded and crash while the other one is being underutilized. So again, the purpose of the elastic load balancer is it's load balancing the traffic and evenly dividing them between any and all of the EC2 instances that it is associated with. So there are a couple of other really important facts that we need to know about elastic load balancers for the CSA exam. And that is, when used within a VPC, an elastic load balancer can act as an internal load balancer and load balance to internal EC2 instances on private subnets. And this is often done with multi-tier applications. So I don't have that diagrammed out here, but what can happen is we can actually have a whole set of private subnets with EC2 instances, and we can use an internal elastic load balancer to divide traffic up evenly between them for an internal application. So just another nice feature of an elastic load balancer, but what I have diagrammed here is actually an internet-facing elastic load balancer. Elastic load balancers will also automatically stop serving traffic to an instance that becomes unhealthy, and it does this via health checks. So what the elastic load balancer is constantly doing is checking with these two instances, or however many instances you have associated with your elastic load balancer, and checking to see if they're healthy. So it's always pinging them saying, hey, are you there? Are you healthy? Can I serve traffic to you? And if they ever fail to get a response or recognize that the EC2 instance has become unhealthy and can no longer serve traffic back to the customer, then what it will do is it will just stop serving traffic to that EC2 instance and then route all traffic to other EC2 instances. So that principle allows for some fault tolerance in that it will stop serving traffic to an EC2 instance that would give the customer an error and routes that traffic to an EC2 instance that will give them a correct response. And lastly, an elastic load balancer can help reduce compute power on EC2 instances by allowing for an SSL certificate to be applied directly to an elastic load balancer. So if you were to apply a SSL certificate to each EC2 instance, then each time an SSL request comes into the EC2 instance, there would have to be processing power and resources dedicated to authenticating that SSL request. But what we can do is we can apply it directly to the elastic load balancer, and the elastic load balancer will handle all of that compute power, then send the authenticated traffic on to either EC2 instance. Okay, so now that we have a good understanding of what an elastic load balancer is, let's now talk about autoscaling groups. So autoscaling groups can also be found right here on the EC2 console under autoscaling, and we have both launch configurations and autoscaling groups, which we're going to talk about. But autoscaling, conceptually, is a service and a method provided by AWS that automates the process of increasing or decreasing the number of provisioned on-demand instances available for your application. Autoscaling will increase or decrease the amount of instances based on chosen CloudWatch metrics. For example, if your application's demand increases unexpectedly, so all of a sudden you have many more users than you expected visiting your website, autoscaling can automatically scale up and add instances to meet the demand and then terminate instances when the demand decreases. So this is known, and we've mentioned this term several times, but it's known as elasticity in the AWS environment. So autoscaling has two major components which can be viewed here, and the first is a launch configuration. And a launch configuration, that is the EC2 template used when the autoscaling group needs to provision an additional instance. So this is where we're going to say, hey, when demand increases and you need to add an EC2 instance, what type of EC2 instance are you going to add? What is the AMI going to be? What is the instance type? Is there any user data? Is there storage? Is there security groups, etc.? So it's very much like selecting or creating our own EC2 instance, but in this case, we're just creating the template for which the autoscaling group is going to use. And then the autoscaling group, that will be the group of EC2 instances, and it also contains all the rules and settings that govern if or when an EC2 instance is automatically provisioned or terminated. So this will include the number of minimum or maximum allowed instances that autoscaling can provision or terminate, also the VPC and availability zone to launch the instances into. It also governs if provisioned instances should receive traffic from an elastic load balancer. And it also contains scaling policies, and these are actually the CloudWatch metric thresholds that trigger scaling. And also SNS notifications, which can be great to keep us informed when actual scaling occurs. Now, this is very important, and I want you to remember this. For architecture to be considered highly available and fault tolerant, it must have an elastic load balancer serving traffic to an autoscaling group with a minimum of 2 instances located in separate availability zones. So that's very important to understand, and I wanted to show you that here on the diagram because this is what I have set up. I have 2 instances, this being a minimum. We could have 3, 4, 5, 10, 20, 1,000 instances, but it has to be a minimum of 2 instances spread across 2 availability zones, 2 separate availability zones, okay, as part of the autoscaling group with an elastic load balancer attached. So what does this do? So this is what allows our architecture to be highly available and fault tolerant. And why is because let's say that this EC2 instance fails. Well, what's going to happen is the elastic load balancer will automatically start diverting traffic from this instance to the healthy instance. And the autoscaling group will recognize that this EC2 instance has failed, it will terminate it, and then replace it with a brand new working EC2 instance. And once that is up and provisioned and passes the health checks by the elastic load balancer will then again start serving traffic to this EC2 instance as well as this EC2 instance. So it's self-healing architecture, and it's going to be highly available because if one of the EC2 instances fails, there's going to be another one for backup. And also if there's any faults, meaning that if an EC2 instance fails, or let's say that an entire subnet or an entire availability zone were to fail, then there was always going to be the other subnet and the other availability zone with the EC2 instance in it that the elastic load balancer can serve traffic to. Now, ideally, you want to have 4 or 5 availability zones with even more EC2 instances to make your application even more available and fault tolerant. Also, with autoscaling, you have the ability for scalability and elasticity. So what can happen is that as demand increases, as more customers start to request traffic, it can add another EC2 instance here in this subnet. It can then add another EC2 instance in this subnet, and you can have 3, 4 EC2 instances in each subnet while traffic is at its peak. And then as traffic dies down, it can decommission and terminate those EC2 instances, and then you can come back to having just your 2 base instances. And that is all controlled by the auto-scaling group. Okay, so that is a fundamental understanding of high availability and fault-tolerant architecture using an elastic load balancer and auto-scaling within your VPC. So now we're going to move on. We're going to have a hands-on lab after this in which we will build out and provision an elastic load balancer and an auto-scaling group to match the architecture that we have here. But for now, we will conclude this lesson. Thank you for watching. You may now move on.